Welcome to the channel.
Hey everyone, and welcome to The Explainer. Today, we're diving into something really fascinating: humanity's relentless, centuries-long obsession with breaking the absolute limits of nature. I mean, throughout history, we've had this deep-seated itch to just cheat the system, right? Whether it's trying to build machines that magically run on nothing, or trying to create totally flat paintings that look indistinguishably real to the human eye, we are going to explore exactly where we hit the hard, unforgiving wall of reality, and where, surprisingly enough, we actually managed to pick the lock. Okay, let's take a quick look at our roadmap for this explainer. We'll start by chasing the impossible, then examine the perpetual motion myth, unpack the physical laws that break those dreams, explore Leonardo da Vinci's optical struggles, and finally look at how we figured out how to hack human perception. All right, kicking things off with Section 1, Chasing the Impossible and the Illusion of Infinite Energy. To really get this, we have to jump way back to the year 1150 CE with the brilliant Indian mathematician Bhaskara. He sketched out a design for a wheel that had these curved or tilted spokes, and they were partially filled with mercury. Now, his reasoning here was wonderfully intuitive. He figured, as the wheel spun, the mercury would flow down to the bottom of each reservoir, which would leave one side of the wheel perpetually heavier than the other. So this constant imbalance was supposed to keep the wheel turning literally forever in a state of dynamic equilibrium, doing actual work without needing any fuel or external energy. It's a beautifully simple idea, but as you might guess, it has a fatal flaw. Which brings us to Section 2, the perpetual motion myth, and why that wheel inevitably stops. Because the hard truth is, a setup like this just acts like a giant pendulum. It might swing back and forth for a while, sure, but eventually it always finds its equilibrium and just grinds to a halt. Moving right along to Section 3, Laws that Break Dreams. It's time to meet the ultimate dream crushers that completely ruin the perpetual motion fantasy, the unforgiving rules of thermodynamics. The absolute crux of the issue here is the first law of thermodynamics. This law outright bans useful perpetual motion, and it does so by dictating that energy absolutely cannot be created out of thin air. A machine can only ever produce exactly as much energy as it consumes. You literally can't get more out than you put in, and because of that, there's never going to be any leftover free energy to, say, power a mill, or drive a car, or charge up your phone. And man, it gets even worse for these inventors, because even if an engineer could somehow perform a miracle and bypass the first law, the second law of thermodynamics basically guarantees failure in the real world. This law tells us that energy naturally tends to spread out and dissipate. Any real physical machine has moving parts, right? And those parts interact with air, liquids, or rub against each other, which generates tiny amounts of friction and heat. Even if you were in a completely perfect vacuum, that heat is escaping energy. It acts like a slow and visible leak, continuously leaching out and reducing the energy available to keep the system moving until the whole thing just stops. I love this breakdown because it brilliantly illustrates how we actually categorize perpetual motion machines into three distinct types, and it's based precisely on which fundamental law of thermodynamics the inventor arrogantly thought they could outsmart. So, a machine of the first kind tries to make energy from nothing. A machine of the second kind tries to spontaneously convert thermal energy into mechanical energy without any cooling side effect. And a machine of the third kind? Well, that one tries to maintain motion forever by claiming to completely eliminate all friction and dissipative forces, which, as we just learned, is completely impossible in any mechanical system. Now you might be thinking, what about modern tech? Well, even highly sophisticated modern attempts fall completely apart under close analysis. Take the Brownian ratchet, for example. It's this thought experiment where a tiny microscopic paddle wheel gets hit by the random motion of gas molecules, supposedly turning a ratchet in only one direction. Sounds amazing, right? Like free energy pulled right from ambient heat. But if you do a thorough physical analysis, it proves that at a molecular scale, that same random Brownian motion would also affect the ratchet mechanism itself, causing the whole thing to fail. From claims of zero-point energy to complex magnetic motors, the reality remains. We simply cannot extract work for free. The universe's ledger, it always balances. All right, so this brings us to a massive pivot in our explainer. We've pretty solidly established that we cannot break the hard physical limits of energy. But what about the physiological limits of human sight? If we absolutely can't build a machine that defies physics, is it possible to build an image that completely defies the brain?
Let's dive into Section 4, Da Vinci's optical struggles and the illusion of perfect sight.
You know Leonardo da Vinci, right? He wasn't just an incredible artist, the guy was a brilliant scientist. But his intense observational skills actually led to a pretty deep frustration for him. As he noted in this famous quote, he realized that a painting, even if you finish it to absolute perfection with flawless contours, perfectly balanced light, shadows, and colors, can never actually show true 3D relief. It's never going to look identical to a natural object unless you literally close one eye and step really far back. He recognized early on that the binocular depth we experience in the real world is fundamentally missing from a flat piece of canvas.
Take this sketch Leonardo did, which proves exactly why art fails in this regard. He drew out a diagram showing two eyes looking at a small sphere. Because our eyes are separated by a couple of inches on our face, their lines of sight converge on the object, sure, but they also look past it on either side. Our two eyes actually see the physical space and background behind a small object. But think about a painted object on a flat wall. It completely covers the background behind its painted outline. Nothing is hidden in real life, but on a canvas, bam, the illusion is instantly broken. And this really beautifully contrasts how our visual system processes these alignments. Leonardo kept returning to this struggle over and over. He documented how a sphere that's smaller than the distance between our eyes obscures distant objects entirely differently when viewed with just one eye versus two. He basically proved that true binocular depth perception completely relies on two distinctly different incoming messages, two different visual angles arriving at the brain at the exact same time. Now, back during Leonardo's time, artists were widely using techniques like Alberti's window. It was basically a transparent grid placed between the painter and the subject to help perfectly map visual angles onto a 2D picture plane. But Da Vinci, being the genius he was, recognized that while this successfully simulated a monocular view from a single fixed point, it still fundamentally failed the two-eye test. A flat painting could never match the perception of a scene viewed with two eyes. The incoming messages were just completely wrong. So, let's move to our final section, number 5. Hacking human perception. Let's see how inventors finally learned to cheat the rules. It actually took a surprisingly long time. Over 300 years after Da Vinci documented his agonizing struggle, an inventor named Charles Wheatstone finally cracked the binocular problem in 1838. He invented something called the stereoscope. By cleverly enlisting mirrors and later on photography, Wheatstone figured out how to present a slightly different, geometrically correct 2D image to each separate eye. Unlike a traditional painting that only provides flat, monocular cues, which our brain instantly clocks as a flat surface, Wheatstone's device fed the brain the exact matched binocular messages it was expecting from a real 3D world. He successfully tricked the brain into synthesizing those two completely different flat images into a single, convincing perception of virtual, three-dimensional depth. He essentially picked the lock that Da Vinci had been pulling at for years.
Fast forward a bit to the 20th century, and a researcher named Adelbert Ames II expanded on this with a really cool concept called equivalent configurations. If you've ever been to an optical illusion museum, you've probably seen an Ames room. He created these highly distorted trapezoidal rooms that, when you view them through a little peephole with just one eye, look exactly like a perfectly normal rectangular room. He proved something mind-blowing. If the incoming visual messages to your retina are absolutely identical, your brain will perceive physically different spaces as exactly the same. We don't actually see reality. We see the incoming message. Control the message, and you literally control reality.
And that brings us to today. Modern virtual reality is basically the ultimate culmination of this hack. It builds directly on these historical insights, utilizing head-mounted displays that update in real time. They are literally slaving the visual stimulus movement to your actual physical body movements, which is actually an idea first explored by a guy named Heine back in 1905. Today's engineers are in a constant battle to perfect this illusion, working on things like hologram-like projections to perfectly yoke our eyes' convergence and focus, all aiming to supply the exact incoming messages of a real 3D space. So, as we wrap up this explainer, I want to leave you with this final thought. For centuries, we tried our hardest to build machines that ran forever, only to get absolutely crushed by the uncompromising laws of thermodynamics. We can never, ever cheat the absolute laws of physics, but when it comes to the complex, physiological machine of the human brain and how we perceive space, well, we found a backdoor. Our genius, it seems, isn't in breaking the universe's rules, but in cleverly bending our own perception of reality. Thanks so much for joining me on this journey today. And hey, always keep questioning what you see.